Good morning and welcome back. This is ACA for Monday after spring break. Our warm-up is on the problem. You need to find the value of C, and then you need to name the triangle. So really quick before we go over it, I'm going to give Bill a chance. What are the two, not two, there's like a whole list of names that we can give the triangles. Let me give me a second real quick. All right, for naming triangles, there's two different sets of names. Do y'all remember any of the sets of names, or any of the names just period? Amelia. We had scalene. What were the other ones that were with scalene? We had isosceles, I-S-O-S-C-E-L-E-S, and equilateral. Very good. That's how you classify it by its size. And then the other three names are by the angles. Let me move this over. Ooh, that's fun. Okay. So then the angles. What are the three classifications with angles? A right triangle, acute, and obtuse. So I like to think of it as you can name a triangle with a first and a last name. It doesn't really matter which one, but you pick one of the blue ones and one of the green ones. Okay? So are y'all ready to go over this stuff, or do y'all need another second to write down from those lists? I'll give y'all another second. All right, let's hop into it. So this first part, the finding the value of C, the ticket that y'all took on Friday, this is probably what we have the most problems on. Okay, because Ms. Lytle had, like, she gave you a triangle, and it said to write the equation. What did y'all learn about triangles on that last week? You learned something unique about triangles, Jack?
You look from all the sides.
Not the sides. If you add up all the angles, it will always equal 180. She showed you that cool little thing where if you cut any triangle, if you cut off the three vertices, put them together, it always makes 180. So where y'all struggled is writing the equation. What is an equation that I could write to show that? Okay, first off, let's talk about what that square means. That square means 90 degrees. Okay, but let's write that equation now. Juliana, help me out. Very good. Okay, of course you can change the order of those numbers because of the the commutative property. The order of addition doesn't matter. You can add those in any order, but all three adds up to 180. A few of y'all did some weird stuff where you said 90 plus 25 equals C. That's not true. Some of y'all did it where 90 minus 25 is equal to C. Not true. I wanted to see all three angles added together equals 180. Okay, and then we solve from there. So what can I add in there? Which part can I go ahead and add? I can go ahead and add those. Do y'all agree? What do I get when I add those together? 115 plus C is equal to 180. Can I add 115 plus C? No, they're not like terms. Okay, what I need to do is solve for C. How do I get C by itself? I would subtract 150, not just from 180, but from both sides, because I want to keep it balanced. Right? Y'all remember that? The seesaw? You don't want a child flying across the sky. Okay, so do it from both sides. Take that away, I get C is equal to 65. 65 degrees. That should have been your value of C. Do I have any questions on that? Okay. All right, so I'm going to go ahead and draw that in. So again, this is 90, this is 65 degrees. And now let's classify it. So talking about scalene, isosceles, and equilateral, that's talking about the side lengths. How many, okay, so they each tell you how many are the same. In a scalene, how many are the same? Zero are the same length. Isosceles, there are two that are the same, and equilateral, 3 or all of them. And y'all saw the cute little way to do it, right? The isosceles, scalene, and equilateral, the little line, how many are parallel? Scalene has no parallel lines, so no equal sides. Isosceles has 2, equilateral has 3. Okay? So in this one, it doesn't give me any side lengths, but it does give me all the angle lengths. Are any of those angles the same? No. So because the angles sort of control the side lengths, if none of the angles are the same, what do you think about the side lengths? none of them are the same. And that's a true statement. We're going to look at that a little bit today, but because of that, we're going to say that it's going to be scaling. It's going to be a scaling triangle because none of the angles are the same, so none of the sides are the same. Are y'all good with that? Okay. Now let's talk about if it's right, acute, or obtuse. In those lessons, you should have heard, thank you, that every single triangle has at least 2 acute angles. And so a quick little way to check what kind of triangle it is, find 2 acute angles, cover those up, and look at the third one. So what's an acute angle up there? 65. Do y'all agree that's acute? Yes. Acute means that it's less than 90. Okay, so 65 is one of my acutes. Then I have 25. My last one is going to tell me the name of it. So it's going to be a right triangle. Okay, are y'all good with that? Okay, those are just helpful tips I've noticed over the years to help me name my things. Okay, are we good with that? Any questions before we move on? Hopefully that's a review of everything. Okay, go ahead, keep your format paper in your resource binder, and then we'll hop into the notes. Ready, set, go. Here we go. All right, so we're going to continue on with triangles. Taking a look at this week, we have a lesson today. Tomorrow we're going to do activities just to sort of refresh from before free break and to refresh on this. But we do have a minor ticket tomorrow, so it's going to be very important that you do your homework tonight. But I'll set you up for that. Okay. Starting off, we're going to talk about something called the triangle inequality. We're going to take the inequalities that we talked about and the triangles that we're going to talk about and put them together. Okay, so what the triangle inequality says. Triangle inequality. What the triangle inequality says is that if you take the side, any 2 sides of a triangle and add them together, they should be greater than that third side. Okay, in the triangle inequality, if I have the 3 side lengths, if I pick any 2 side lengths, they should, when you add them, it should always be greater than the third. So it states that the sum of any 2 sides of the triangle must be greater than the third. And does that make sense? If you take 2 sides, it should be more than the third one, right? Does that make sense? If it's equal to it, is that going to work? No, it has to be greater. Okay? So this one is going to tell a little story. It really doesn't make sense in the recording, so I'm sorry for those Okay? So again, the summary of the story, when you take those 2, it finally makes a triangle because they're too long to be exactly equal. They stop because those 2 are greater than the third one. Does that make sense? Okay? So the rule is you can do any combination. So this says that A plus B, that has to be greater than C, but you could also do different pairs. You could do A plus C, those lengths. If it's longer, then it works, and it has to be true for all of them. Most times you can take the 2 smallest sides, and we'll see this in the lesson today. Usually you can take the 2 smallest sides and check that, and it usually works for all of them, and I'll show you what I mean by that. Okay? So this is just important. We don't really need to write anything, just must be true for all of them. Okay? All 3 sides, yeah, it has to be true for all of them. So not yesterday, but before the break, we learned about some special stuff about an isosceles triangle. In an isosceles triangle, how many are the same? 2 are the same. Okay, so we said like those 2 are the same. What did we learn about the angles of those 2 isosceles? Not always. That's not necessarily true. I can draw an obtuse isosceles triangle. But you learned something special about the angles. Okay, so like this side. Let's give it a name. So let's say X, Y, Z. Triangle X, Y, Z. Which angle controls this side right here? Which angle? It's the one that's opposite from it. So angle X, right? Okay. Which angle controls this side? Z. The one across from it, Z. So we talked about how if those 2 side lengths are the same, what's true about those angle measures? Amelia? They have to be the same. Okay? When these 2 angles, this one right here and this one right here, the angles opposite are also going to be equal, okay? Because they open it the same amount. We talked about that. That should have been in your lessons. Yes, ma'am. Yeah.
So then the bottom one is y control the bottom one.
Very good. Okay, angle Y would then control this bottom one. But that one doesn't have any special rules. That's the ones that are opposite from the so we learned that if a triangle is isosceles, then the angles opposite the congruent sides are also congruent. Hopefully I'm going to be able to make a little connection here. Okay? In an equilateral triangle,
All three sides are the same.
all sides are the same. What do you think that's mean about the angles? Exactly. Okay? Because the angle, again, is controlling how much it's opening. So if this angle is the same as this angle, is the same as that angle, they're all open the same amount, so it's going to have the same lengths. Yes, sir.
So the angle depends on the side.
Or even the other way around. The side depends on the angle. Either way you can cover it. Okay? So, sort of a way to imagine that. I'm going to just watch what I'm doing. You don't have to fill in this part yet. I'm about to draw on this triangle, but you don't have to quite do this yet. So, how many of y'all have been to movies ever before in your lifetime ever? Okay, been to a movie theater, seen it on the big screen. Okay, a lot of y'all are not raising your hands on it. Okay, y'all have been at the movie theaters. Okay, thank you. They have that big screen that's controlled by this little itty bitty projector that's over here. It controls this whole big screen, right? It makes this big screen. So this sort of relates to the lesson that we're talking about. This projector, this little angle right here, controls the screen, the side that is opposite of it. Do y'all see how that connects? Yeah. Okay. It's that tiny dot makes this huge screen. Okay. That's sort of how we talk about triangles. The angle over here controls the side that is across from it. Okay. And that's sort of what's talking about here. With those two isosceles triangles, those two sides are controlled by the angles opposite, so they're the same angles. With an equilateral triangle, all three sides are the same, meaning the angles are all the same. Is that sort of making a connection? Yeah, sort of, kind of. It's also Monday, the fun one. I can't believe you're making this stuff.
Oh my god,
Okay, so in an equilateral triangle, since all three sides are congruent, all three angles are also congruent. And then lastly, y'all talked about an equilateral triangle. What was true about the angles of an equilateral triangle? They always equal. They always equal 180, and if all three angles are the same, all three sides are the same, but the angles
equal what? 180? No, the sum of the three angles equals 180, so each angle equals.
correct. Okay? So like this is an equilateral triangle, yes?
Yes.
Yes. And so this angle is going to be the same as this angle is the same as this angle. Was this in the lesson? Okay, I was just like not. Okay. So because they're all the same, what number, if I did x plus equals 180? How many x's do I have right there? 3 x's is equal to 180. So what is the value of x for that to be true? 60. Do y'all remember that from the video lesson? In an equilateral triangle, those angles will always be 60. That should be reviewed. It should always equal 60. Yes? Okay, some of y'all are giving me some blank stares. There was a video.
Okay.
All righty. Now the last little bit, again, it's just building off of that some more. So there's a special relationship between the longest side and the largest angle. Let's call this triangle. Y'all will write this P, Q, R. P, Q, and R. Now, which of those angles do you think is the biggest angle?
Q.
Q. Y'all agree with that? Okay, I'm going to label. I'm going to say this one right here, largest angle.
No,
Okay, I would say Q. Let's just say, for argument's sake, that Q is my largest angle. Okay, which side does it control? The bottom one, the one that's across from it. It's this red one right there. So, because that's the largest angle, what do you think is true about this side? It's the longest side. And that's exactly true. Okay? most times, in any situation, I will actually tell you which one's the largest letter. Okay, which one do you think is the smallest angle?
R.
P. I would say P is smaller. Tiny.
Yeah.
Okay, so I'm gonna say that's the smallest angle. And therefore, which one's gonna be the smallest side or the shortest side? QR or RQ, whichever way you wanna call it. This one right here, because it opens up to that one. This is gonna be my shortest side.
That's how you determine if one of the angles are smaller.
Mm-hmm.
So you could just look at the sides.
Yeah, you could. Okay, again, most times I will actually give you the numbers so you can actually back it up with facts. Not facts. Kristen.
It always should be the smallest angle. It also control the smallest side.
It's always true. Okay, so what could I say about the largest angle and the longest side? I could say they are across from each other. They are across.
They are part of a triangle.
But let's be more specific. They are across from each other. Okay. What can we say about the smallest angle and the smallest side? They're across from each other. The same exact thing. Okay, I'm not even gonna rewrite it. Yeah. Okay. So now we're gonna practice all of that information that we just learned. Okay. So once you're done copying, flip on to the next page. Alrighty, so let's look at some examples to practice that information. So number one, it says to order the side of the triangle from least to greatest. What order? Least to greatest. So I'm going to rewrite that. Or rewrite it. Okay. But what did it? Okay, it wants me to order the side length, but it gave me what? It gave me angle. Okay. Okay. So what we're going to have to do is we're going to have to use that information. Okay. So this is the angle. This controls that top. Okay, a couple of things before we go into this. When we label sides, there's a couple of ways to do it. So I'm just gonna like highlight this. You don't have to write this down, but just watch. This side that I have right here, there's a couple of ways you can label it. You could say that it's side RT. You could say it's side TR. Are we agreeing? Those are the two endpoints. Do you agree with that statement? TR and RT. Do y'all agree with that?
Yes.
Okay. You could also use one letter to describe it or to label it. When you're using only one letter, you're going to use the angle that controls it. So you could also say that's side S. Okay, side S. Does that make sense? Sort of, kind of. It uses all the letters, so it's extra confusing. But that's just a little fact. Now, we're going to use that in order to answer this question. You didn't actually need to write that down. So we want to order the sides in order from least to greatest. When I do that, I like to start with the information I'm given. Can I order the angles from least to greatest? Yeah. Okay, which is my smallest angle? Angle S, or the 53. So I'm going to put a little S for small. Which one's my medium? T. And then R. Okay? Again, that's not my answer because this is an angles, small, medium, and large. I need to figure out what sides it controls. So since I'm starting with the least, I'm going to start with the smallest angle. So that's over here. What side is controlled by angle S? Use two letters to label it. Side. It's side RT. Okay, it's this side right here. Do we agree with that statement? Again, I put those in and L for the medium and large. Don't let that distract you. That would be side RT first. Okay, then I'm going to look for my median. This median controls side, what two letters? Nope. Let's try that with the letters that are there. RS. Okay, and then lastly, my largest side, my greatest side is side TS or ST. Okay, again, these green letters in this title are for the small, the medium, and large. Those aren't actually the names of the sides. Okay, I was just labeling them smallest to largest. Okay, yes. Question? Okay, so again, I could also have put side TR, SR, and TS. Math teachers like order, and so I will typically put it in alphabetical order. just because that's working as a first. Okay? But again, RT, if I use one letter to label this side, that would be side S. I'm just going to write it underneath. Side RS, if I use one letter to label it, it would be side, right out. This side is the same thing as side T. And then side ST is also known as side R. Okay, the slide will accept either one. I will typically do it in this top version. I'm just letting you know, honestly, math can change it all up. Okay. All right, let's do another one. Okay, on this one, I'm going to order the angles, but they gave me the sides. Okay, so we have to do it again. We're ordering the angles in what order? Greatest to least. So we're starting with our biggest to our smallest. So which is my biggest side? Use two letters to explain it to describe it. What side is the longest? M to N. This is my longest side. What angle controls that? Angle L. So when I write angles, we put a little symbol. It's the angle symbol. It looks like the less than symbol, but it's a flat bottom. Okay, angle L is my longest. Okay, next, which is my median? Side L to N. Okay, and that's controlled by which angle? M. So that's going to be angle M. And then side M to L, or if you use one letter, and that was correct too. And what angle is controlled? That angle N, as in Nancy. Okay. So just like with sides, when I label an angle, you could use one letter to explain it, where it's just the vertex. Okay. So like when I say angle L, that's talking about from here to there, correct? And it's just the vertex of that point. Y'all agree with that? Y'all understand what I mean by the vertex? It's the point of that angle. So angle L. But another way you could write that angle L right here, is you start at one point. So the other one, let me write it first. It would be angle M, L, N. Because you're starting from M going to L, N. That center letter is your vertex. Do you see that? Okay. Technically, I could also write angle N, L, M. Because it's N to L to N. Okay. Again, that middle one has to be the vertex. So pick one of those to write for the same, right under angle L. Okay. Technically, all three of these are talking about the same angles. Okay, so let's try it again with angle M. So angle M is this one right here. Ooh, that's right. Okay. What? Does someone want to try it? That would be the same thing as angle
L, M, N.
Very good. L, M, N, or N, M, L. Okay? Noticing that vertex always stays, it didn't line up quite as nicely, but that vertex stays in the middle. Okay? And then lastly, with the green. With the green. That's angle N, so that's this one right here. Okay, let's try it again. L, N, M, angle, L, M, no, N, M, or angle. We knew the alphabet would be so hard. No, that's not what you're. Alright, so what I want you to do is try these three. So on this one, it gives me the side lengths. I'm probably going to need to order the angles. If they give me the angles, I probably need to sort the sides. What order are we gonna do it in? From
Least to greatest.
least to greatest. Try the three right there. So let's look here. We want to go from least to greatest. One of the strategies Miss Lionel showed us was saying small, medium, large first. Which one's my smallest? 17 is my smallest, then 21, and then 35. Now we need to find the angles that control it. Which angle controls the smallest side? Angle H. Next, what angle controls this side? What controls this side right here? Which angle controls that side? Angle F, and then angle G. If you wrote it in the three letters, the middle letter should be H, then the middle letter should be F, and then the middle letter should be G. The other two letters can change, but that middle. Does that help y'all get started? Okay, because some of y'all still haven't even attempted that first one. Small, medium, large, find what controls it.
Oh,
All right, I need to do one more column with you really quick. Okay, so number 5, you'll check them on here. So number 5, it's talking about Evelyn bought 3 railroad ties from the sides of the triangular flower bed. 2 of the ties were 9 feet long, so there's a tie. Each one of those is 9 feet long, and then one that is 15 feet long. We need to see if we use those 3 side lengths if it would form a triangle. Now this is where we go back to Miss Lytle's story time. If I add any 2 sides, it needs to be what than the third side? It needs to be greater than the third side. A quick way to do this usually is to take the 2 shortest sides. What are the 2 shortest sides in this? Taking 9 plus 9, and again it needs to be greater than 15. So let's check and see if that is true. 9 plus 9 is 18. Is that greater than 15? Yes. Okay, just to be sure, I'm going to do a different combination. I'm going to do 9 and 15. 9 plus 15 needs to be greater than the third side, which is 9. 9 plus 15 is 24, I'll just tell you. Is that greater than 9? Yes, okay? And if I did another pair, it would be the same inequality, and it works out. So, I always take the 2 shortest sides, add them. If it is greater, it works out. If it is less or equal, it does not. Your homework tonight is going to be to complete just the odds. Okay, we didn't get target practice time because we were talking and reviewing. But please make sure you do those odds. Tomorrow we will have practice and then a ticket at the end. Okay, please check Canvas tonight. A few of y'all need to come in for makeup work in the morning.